Now I have here what we're going to use basically as a reference in order to try to solve our problem, and that's going to be in green, and our actual problem itself, which is 2y minus 8 equals 24, is going to be in yellow. So in this little mini equation, so to speak, we basically have set two values equal to each other, and this is actually true. We've set 10 equal to each other. So 10 equals 10. That's obvious, because, if you were to do the tally marks, 10 is equal to 10. Basically, we've established that. This is a separate property, actually, when we get into, like, properties of, pre-algebra. But that's for a different day. For right now, just remember that 10 equals 10, regardless of what world you're in. I'm just going to fill this in real quickly. Anyways, 10 equals 10, regardless of what world that you're in. Now, let's say we wanted to increase this value that we have going on. We have 10 equals 10, but let's say we wanted to get up to 6. Well, let's say we wanted to add 6, so to speak, to 10. So now we have 16, but wait. This equation, it isn't right. 16 is not equal to 10. How are we going to have this work? 16 is not equal to 10, and I wanted to add 6 to it. Well, this may seem pretty basic, but the obvious answer is to add 6 to the other side. Because even if we are adding 6, we go from 10 to 16. And I'm going to try to pull this off. Okay, that's good enough. So by adding 6 to both sides of this equation, we've netted a similar equation, and this works again. Let's say we wanted to add 2 to this side. This is going to be a value of 18, but this isn't going to be equivalent to this equation. So basically what we have to do this to the other side to net 18, and 18 is equivalent to 18 again. This is good. This is good. This is good now. Forget about that. And the same works if we wanted to subtract to it. If we want to subtract 7, as long as we subtract what we're doing on both sides, we get a equivalent equation. If we wanted to multiply this by 2, then we get 22 equals 22. We're basically doing things with these numbers, and as long as we're doing things with these numbers and we're making sure we do it to both sides, if this is like a little side thing, as long as we do things to both sides, we're gonna get an equivalent answer regardless of what we do. Now let's forget about this. This is a very good little equation for two-step equations, but let's forget about this for a little bit. And let's say that we wanted to do something with something simple as y plus y equals y. We're going to say y equals y. And in essence, this is true. No matter what value of y is going to be, it's going to be equal to itself, right? It's common sense. And what we're going to want to do now is multiply a 2, so to speak. We could make it 2y, but if we're going to multiply by 2 on one side, we have to multiply 2 on the other side. This is why the golden rule in pre-algebra is basically put, do to one side what you do to the other side. So, for example, if we wanted to add 1 to this equation, we'd add 1 to it. And what would happen now is y plus 1 will equal y plus 1, right? Yes, because y will always equal to y. Y will always be equal to y. So y plus 1, let's say y is equal to 2. 2 is equal to 2, but 2 plus 1 is also equal to 2 plus 1, because we're basically setting it equal to 3 now, right? So, taking this principle, which is the golden rule of algebra and pre-algebra, do to one side what you do to the other side. This is the basics of pre-algebra. Do to one side what you do to the other will always net you an equivalent equation. Now recall that in pre-algebra, what we do when we're solving equations is we basically go in the opposite order of PEMDAS. Why? Because it works. So we have PEMDAS basically in the upside down, so to speak. First thing we're going to want to do is subtraction or addition. Basically we're going to want to do any addition/subtraction problems. They basically negate each other out. If you don't understand what I mean, y plus 1 equals 2, you're going to be subtracting on both sides. This is basically the reason why way back when I was doing it to both the sides. Basically what we're doing is, what we do to one side, we do to the other side, and it'll always net the equivalent equation. So y equals 1, which is basically saying 1 plus 1 equals 2, so that's right. But basically addition and subtraction go together, division and multiplication go together, and exponents and parentheses do not go together. And let's forget about what I said right there. First thing we're going to do now, considering what we just learned, is to add 8 to both sides. So we add 8 to both sides because we have to do to one side what we do to the other side, right? So this is one side of the equation to the other side of the equation. So what we do next is basically we're adding 8 to both sides. Is basically what the proper term is. And by adding 8 to this side, we get what we could call 2y minus 0, because we're not subtracting anything from it. We were used to be, but we're adding 8 to it. So now what's happening is this is no longer affecting this variable anymore. So why write 1 minus 0, so to speak, when we can just write 2y itself? So basically now we have 2y equals 32. And now what we can do now is the next step. So we finished subtraction and addition. You don't really have to worry about that. Next thing is we have to do division and multiplication. So in this scenario, what we're going to want to do next is indeed divide both sides by 2. Recall, what you do to one side, you must do to the other side. So by doing this, now we net that y equals 16, which is basically the solution to this equation. 2y minus 8 equals 24. That's great. My answer is y equals 16. And let's look through this one more time. We use this when we're going in the opposite order of solving two-step equations. Why? Because it just works. No, but what we do now is first, because it's subtraction and addition. Anything to do with subtraction and addition, we do first. In this equation, we have 2y minus 8 equals 24. We have minus 8 being going on to this. So what we do is we have to add 8 to both sides. We could, in theory, netting us a simple equation, we could also add 3 to both sides. And what would happen is it would just net the it would just change this equation to 2y minus 5 instead of that equals 27. And this would work as well, because as you know, what happened next is add 5 to both sides. You can really do anything you want to this equation. It'll always net an equivalent equation as long as you do it to both sides. So basically what we figured is, hey, if we add 8 to both sides, we're adding it to both sides, so it's going to be equivalent. We're doing the same action to both sides. It's going to be equivalent, but it's going to bring me closer to the answer because it's going to cancel out this variable, cancel out this constant. It's going to cancel out the minus 8 being done to this equation. And we're going to have to add 8 to both sides, because what you do one side, what you do the other. And now we're just left with 2y equals 32. And again, we could divide this by any number that we want to net us an equivalent equation. But to find out what we want to do, to find out what we're going to do to this variable, we're going to want to divide by 2, because that's anything that's being done to the variable. We're going to have the variable by itself. This is the golden ticket to happiness. This is happiness ensues after you get this number. But getting to this number basically involves us, doing things to variables in order to find the answer that we need. Now, what we can do now is, if you don't believe us, if you don't believe me actually, we can basically take this equation and plug it back into the main. So let's see, it's 2y minus 8 equals 24, and we assume that the value for y is going to be 16. So 2 times 16 minus 8 equals 24. Well, 2 times 6, remember PEMDAS, or PEMDAS. This is for equations that you don't know the value of y for. I know I said something different earlier, but that was just to get you guys to grasp the concept. You always follow PEMDAS when you're doing this as well. 2 minus 2 times 16 equals 32 minus 8 equals 24. Okay, and 32 minus 8, if you recall, is 24. So we found the right answer. Now just a quick wrap, just in case I confuse you guys by saying something last part and saying it again this part. Technically, this could be viewed as a as an expression, so to speak, because if we were to get rid of this, we'd still get we still get 24, but you know, now it's an expression. It's kind of complex. I mean, it's kind of hard to explain when to use what, except for when you have a variable, use the opposite of PEMDAS. When you have a regular equation that you know the values for, because up until then we were going to have to do PEMDAS now to figure out the equation, figure out the value of y. But now that we know the value of y, we're just going to plug that back in to our equation. So we're basically doing PEMDAS because we have all constants. I guess that's a pretty good way of saying it after all. When you have constants, you use PEMDAS. When you have to find a variable, you use the opposite of PEMDAS. Now there's going to be one quick little tutorial in the next part, and after that, we are good to go with Unit 2.